In this problem, we have a sinusoidal current with a maximum amplitude of Ipeak equal to 90 amps. We know the current passes through one complete cycle and t is equal to 11.50 milliseconds. We're going to find the RMS value of the current. We're going to find the frequency in hertz, and then what frequency W in radians per second. And the frequency W is our angular frequency, or omega. In looking at this, we are going to use these two formulas right here. They can be found in the notes linked below, section 9. And we're going to start with A first. So what is the RMS value of our current? Well, for this, we're going to look at our first formula right here. Now, this is in voltage, but this is actually interchangeable with current. So we can note this down because it's not specifically in the notes that says this, but this is interchangeable with current. So we're going to have our IRMS equal to our 1 divided by the square root of 2 times our IP or IM. And the M and P is just max and peak, so they kind of mean the same thing. So all we need to do is plug in our values. We know that our Ipeak is equal to 90 amps, and that's what's going to be in here. If we plug in 90 divided by the square root of 2 into a calculator, we are going to get approximately 63.64 amps. Now we are going to look at the frequency in hertz. We're given the cycle, which is that t is equal to 11.50 milliseconds. And we know that frequency is just the cycle inverted, or frequency is equal to 1 over t. Before we do this though, we need to convert our milliseconds into seconds. We are going to have 1 over our 11.50, and we know 1m is equal to 10 to the negative cubed. So we're going to have this in here. So when we plug into our calculator, we're going to have 1 divided by left parenthesis 11.50 times 10 to the negative 3 right parenthesis, and that is going to give us 86.96. That's the answer for part B, and now we're going to go to C. So we have what is the frequency omega in radians per second. If we look in the notes, again linked below, we have the omega formula as omega is equal to 2 pi times our f. We know our frequency, we actually just found it. It is 86.96 hertz. So all we need to do is plug this into a calculator. If we do this, we are going to get approximately 546.4. And that is how you would go about solving this problem. If you want more introduction to circuit analysis, there is a playlist and notes linked below in the description that has the entire coursework for this material.